All right, so we are going to graph our data from our gravity lab and several other labs during the year. And I want to use this opportunity to kind of start at the very beginning and make sure that everybody's on the same page when it comes to graphing data. I know you've used graphs before and I know you've made graphs before, but I want to make sure that everyone starts on the same page. So we're going to create a scatter graph. So let's start off with the parts of a graph. The first thing that we want to do is we want to title our graph. Now in science, there's a convention that we use. We have the dependent variable versus the independent variable. All right, so in our lab, we hung different masses from a spring scale. So I was in charge of the mass, so I changed the mass. So that means that the independent variable was the mass. When we changed the mass, the force of gravity changed. So the reading on our spring scale changed every time we changed the mass. So the dependent variable was the force of gravity. So our title then is going to be the dependent variable versus the independent variable, or the gravity force versus the mass. So then we want to look at our x-axis. Again, by convention, in science, the x-axis is where the independent variable goes. So I changed the mass, so the independent variable is the mass. And we measure that in kilograms. So on your graph, you want to title it with the independent variable, and in parentheses, put the unit that we measured it in. So in this case, it'll be mass, parentheses, kilograms. And then we want to scale it. So what everybody always wants to do is put this itty bitty little tiny graph down in the bottom corner. We're going to be doing a lot of things with our graphs, and we really want to be able to see it. Okay, so we're going to use our whole page for our graphs. So the first thing that we're going to do is we're count how many spaces are from our origin over to the edge of our x-axis. And if you look at that, it's roughly 50 spaces. Now, if it's 52 or 48, we can kind of round up. So that'll kind of give us a little bit of easier time on our math if we have 50 instead of 54. So we're going to say that there's 50 spaces going across on our graph. So now you're going to divide your range of masses by 50. Now what was really important here is we measured our mass in kilograms. So the highest that you probably measured on your mass was 1 kilogram. So we want 0 to be over here on our origin, but we want 1 to be clear over here on the edge. So we're going to take that 1 and we're going to divide it by 50. Because there is 1 kilogram that we have to fit into 50 spaces. What that means then is every space on our graph is going to represent 0.02 kilograms. So from here to here is 0.02, 0.04, 0.06, 0.08, and then 0.1. Okay, so every 5 spaces is going to be 0.1. So if we count over 5 spaces, it's 0.1. Another 5 spaces is 0.2. Another 5 spaces is 0.3. Another 5 spaces is 0.4, and so on all the way across. And then we're going to do the same thing with our y-axis. So if we put our independent variable on the x-axis, we are going to put our dependent variable on the y-axis. And in this case, our dependent variable was the force of gravity, and we measured that in newtons. We're going to do the same thing. We're going to count how many spaces there are up the y-axis. Now I'm pretty sure if you count this, there's something like 60, but 60 is kind of a weird number because it doesn't divide well into a lot of our ranges. And so we're just going to say 50. That'll give us enough space and a big enough graph that we'll be able to do what we want to with it. So we'll go up 50 spaces on our graph. We're going to do the same thing. We're going to divide our range of forces by 50. Now, if you had a 1 kilogram mass, chances are pretty good that the highest force that you measured was 10. All right, so that's the range of our forces. So we're going to take that 10 and we're going to divide it by 50. And so what this means is that every space is going to be equal to 0.2 newtons. So from here to this first space is going to be 0.2, and then 0.4, 0.6, 0.8, 1.0. So every 5 spaces will be 1 newton. So if we go up 5, we're going to put 1 newton. If we go up another 5, it'll be 2. Another 5, it'll be 3. Another 5, it'll be 4. And again, so on and so on until we get to our range. All right. So now we've got our graph scaled. Okay. So we have our axes scaled how we want them. So now we're going to graph our data. All right. So if you look at your data page, we are only going to graph the average. So everyone in your group measured the force, and then you averaged them. We're not going to graph every single data point. We are only going to graph the average. And I highly recommend that you use pencil. Okay. And one thing that you do in math is you typically add numbers to the points. We don't do that in science. We have a data table. If we want to know exactly what that point is, we can go back and we can look at it. But we don't really want that on our graph. And then we're also going to estimate in between the graph lines. So if you need to, it might not be exactly on a line or on a point. You're going to need to estimate in between. And we aren't going to round this. And then you're going to graph your data. Start with your first data set. All right. You're going to go over that amount of mass, up that amount of force, and put a dot. Go over the next amount of mass, up the next amount of force, put a dot. And you're just going to do that with all of your data sets. Once you have that, you're going to draw a best fit line. You're not going to connect the dots. Okay, so you're not just going to go from 0 to this point, to this point, to this point, to this point. We have the rulers. If you go over to the ruler drawer, there are some clear flat rulers with kind of a line down the middle that will help you line up your best fit. So the best fit line might not go through all the data points. It might not even go through any of the data points. It's kind of, if you think of it, kind of an average of all of your points. That's what you're actually going for. And it might not go through the origin. We actually don't want to use 0, 0 as a data point because we couldn't measure that. All right. If you have 0 mass, you have 0 force. We didn't measure that. So we do not want to use 0, 0 as a data point. So don't line it up here. Line it up just with your data points. And then use a ruler to draw a line through kind of the average of those points. Now what you'll notice is this one's pretty close to the origin, but not quite. Okay, so notice I did not use this as a data point. So it goes through most of my points. And if you look at it, this is a pretty good kind of average. They're pretty close to that line. All right, so that's what we mean by a best fit line. All right, so now that we have our line of best fit, we are going to determine the slope of the best fit line. Okay, so when we find the slope, we're looking at the line. So we're not necessarily looking at these data points. We can certainly use those data points, but we really want to look at the slope of the line. Now, slope is the rise over the run, right? So it's how much our graph goes up compared to how much our graph goes over. And to find that, you're going to pick 2 points. You're going to compare those 2 points, right? So when we say y2 minus y1, what that means is whatever point we pick to be y2, we're going to subtract it from the value of y1. Same thing with our run. Whatever point we pick to be 2 is going to be the x value minus the x value of 1. And again, we're going to use the line. Okay? So pick 2 points. All right, so down here, I picked this one as my point 1. All right, so this right here is my point 1. Notice up here, I did not pick an actual data point. Okay, so my point is right here in the middle, but it's not a data point. But it is on the line. Okay, you'll see why I picked that one here in a minute. So start out by discovering what y2 is, right? So here's my data point. This is my point 2. So the y value of my point 2, I'm just going to read on the graph. I'm going to start here, I'm going to come over here, and I'm going to read it. So the y value of my point 2 is 10 newtons. And then I'm going to do the same thing for point 1, right? So my y value for point 1, I'm going to read over and read it to be 1.5 newtons. So these are my y values, right? And we just get those off the graph. So that gives us the top part of our slope equation. y2, which is this one right here, has a point 2 has a y value of 10 newtons. Point 1 has a y value of 1.5 newtons. So what that means is from y1 to y2, we have increased our force of gravity by 8.5 newtons. Okay, so from this point to this point, our graph goes up 8.5 newtons. Now we're going to do the same thing with our x values. So go back to point 2, follow it all the way down to the x-axis, and see that the x value of point 2 is 1 kilogram. We're going to do the same thing with point 1. Find this point, come down on our graph. The x value of point 1 is 0.15 kilograms. So that's going to be the bottom of our slope equation, right? So point 1, or point 2, I mean, point 2 has a value of 1 kilograms on the x-axis. Point 1 has a value of 1.5 kilograms on the x-axis. So when you subtract those two, you get 0.85 kilograms. So this is how much the mass increases. So from this point to this point, our mass increases by 0.85 kilograms. So our force went up 8.5 newtons, and our mass went up 0.85 kilograms. So we're going to divide that to find our slope. We're going to find our slope has a value of 10. Now, we're in science class, so we do not have naked numbers. We always have a label on a number. If we write a number down, it has a label. All right, so in this case right here, the value of our slope is 10. And if we look at our labels, right, on our y-axis we have newtons. On our x-axis we have kilograms. So these are going to multiply and divide just like numbers do. So our label for our slope in this situation is newtons per kilogram. So our slope is 10 newtons per kilogram.